Good morning, everyone. Am I audible clearly?
Sir, good morning, sir.
Good morning. So, ask your friend to join as soon as possible. Okay, today is 10. So, this is your class of professional elective 1 of 6th semester, and the name of the subject is your railway engineering. So, we have already completed module 1. So, in the last class, we have started the module 2, starting from wheel and axle arrangement. So, if you remember, uh, in the first last week, that means on Monday, I guess, last Monday, we have started second module of railway engineering, and we have discussed wheel arrangement. There are two methods which can be used to define a particular locomotive. Okay, white notation and AAR notation. Okay, so I'll wait a little bit, ask everyone to join. Okay, so we will not wait so far. So am I audible, right?
Yes,
So,
sir.
Okay, ठीक है. So we'll start. So today we'll discuss about coning of wheel. Okay, so first of all, let me start my sharing. So we'll discuss about this topic, coning of wheel. Is it visible? My screen is visible.
so
Okay. So what is the name of
No,
the
sir.
topic? Okay, what is the name of the topic? That is your coning of wheel. Okay, so basic definition. Why we're taking this topic today? Because this is a very important part of railway engineering. Okay, so before going into deep discussion on coning of wheel, let me tell you about basic component of railway wheels first of all. Okay, so here you can see you can concentrate any one here or here. You can concentrate any one of the image. Here you can see this is a particular image of a wheel line diagram. Okay, so this is a wheel. This is a wheel. This is the axle. Okay, the axle is used to connect to wheel. Fine, and if you look in closely in the wheel, you can see the shape of the wheel is not circular or plane. Okay, anyway, before that, so this is your wheel, and wheel have some part. This part is called flank. Okay, the inner part of the wheel is called flank. Okay, and the circumference of the wheel is called wheel tread. There you can written the wheel tread. Okay, about which a rail move, it's called wheel tread, or you can say rim, just like your car rim. Okay, if you drive car, it within a wheel there is a rim, right? So it's same kind of thing. Okay, so this is the rim part, or you can say wheel tread. Tread, wheel tread. This part, the inner part is called the tread. Okay, this is the axle. Fine, and you can see it is written here coning of wheels of tread. That means if I give some here, wait, I'll take one pen. That means the wheel, basically if coning is not given, the wheel should be like this, isn't it? Thickness ज़्यादा हो गया रुको, है कि नहीं? So it is not given in a horizontal or plane. Fine, it is given as a cone. How it cone? It's given at in this direction. Can you see? Even if I extend this part like this, isn't it? So now can you visualize this? The wheel of the rail or wheel of a train is make is not horizontal or parallel. It is make in a angle. That means it make in a cone. So this slope is provided. Okay, and what is the amount of the slope? 1 in 20. Okay, what is the slope of this cone? 1 vertical in 20 horizontal. 1 in 20. Okay, this cone, the making of this cone is called coning of wheel. Okay, now why this coning of wheel is provided, we are going to discuss in this class. Okay, okay, you can see the cone is provided at here also, even here also, here and here. Okay, now suppose a wheel is or particular train is moving in a right curve. So, okay, suppose this is a curve or in a curvilinear track. I'll show you. Okay, suppose like this. Okay, suppose this is a curve. Okay, curve ऐसा नहीं होगा, इधर होगा. Wait, let me draw clearly. I'll take a different track. Okay, now can you see? So suppose this is a curved track along which your rail is moving or train is moving. Okay, Now, particular in this curve, in this position, this is your outer curve, this is your inner curve. Got it? This is the outer curve, sorry, this is your inner curve, and this is your outer curve. Fine. Since it's taking, the train is moving in a right curve. Okay. Considering right curve or taking the right turn. Okay. So in that particular position, the wheel in the outer curve is considered as a outer wheel. Okay. Now wheel which is moving along the inner curve, it's called inner wheel. Very simple definition. Okay. So this is your inner wheel and it is your outer wheel. Okay. If you consider a right curve and if you consider a left turn or left curve, that then this become your outer curve. This become your inner curve. I think it is very easy to understand. Clear? It's basic geometry. Fine. Okay. So we'll start from here. So you already got these things. What is coning of wheel? Fine. The surface of wheel, or you can say tread or rim of wheel. That means this surface. I'm talking about this surface. This surface. Okay. Or this surface. The surface of wheel is made in cone shape at an inclination of 1 in 20. At an inclination of 1 in 20. I told you na how to give this 1 in 20, 1 vertical in 20 horizontal. And this is known as coning of wheel. This is the coning of wheel. Basically, the, the making of the wheel in a cone shape. In a cone shape, how it make in cone shape? By giving an inclination of 1 in 20. Okay, and this is called coning of wheel. Okay, the diameter of wheel is different at different cross section of the wheel, and it maintain vehicle in the central position with respect to the track. Okay, that means the difference, the diameter of the wheel is different at different cross section. Now again, I want to draw the same diagram. Let me draw. Okay, wait, let me draw the cone. Okay, so the cone is given in this direction, isn't it? Okay, so if you check this diameter, if you consider this diameter is smaller than this diameter, so at different point your line is increasing. So if you consider this is a diameter of the wheel is smaller than this. Okay, that means we can say at different cross section of the wheel the diameter of the wheel is different. Clear? Because of the coning of wheel. You can see if you consider this is your wheel, this is your inner face, this is the outer face, the diameter of the wheel near the outer face is smaller and it is go increasing towards the inner face. Okay, and finally it reaches the flank. Okay, flank is has the larger diameter. Got it? Similarly for this wheel also. Got it? So the surface of the wheel is made in cone shape at an inclination of 1 in 20. This is known as coning of wheel. And the diameter of the wheel is different at different cross section of the wheel, and it maintains the vehicle in central position with respect to track. Central position means it maintains the CG, center of gravity of wheel, at the rail part. This is suppose this center part. Okay, this the middle part is called center part. Okay, fine. The center of gravity will lie here only. Okay. So when the train is moving on a straight track, will try to move in any direction, and the diameter of the wheel increases over one rail, and the wheel assembly is automatically forced to move back in its original central position due to difference in distance moved over two rail. That means when the train is moving in straight line, now if you consider the first drawing, so this drawing is with this is respect to the straight track. This is your straight track. Okay, in this straight track the wheel is moving in a straight direction. Fine, and the point of contact of the wheel with the rail. This is the rail part. Okay, this is rail and it is fixed with the slipper. This is the slipper part. Okay, so the contact point of the wheel with the rail, it may be deflated at some point, but finally it will automatically come to the central position. So wheel centrally placed on rail. You can see this is written here. When the train is moving on a straight track, wheels are centrally placed on the rail. This is a rail, okay, and this is a wheel of the train, and it's always at this point. The point of contact is at the center point of the wheel. Got it? Okay. Now, if we now we'll discuss about curve. Okay. Suppose we are considering right curve. That means in a right turn, in a curve track. In that case, the diameter of the outer track is more in curved path than the inner track. That means if you consider a curve, okay, I'll draw again one curve here. Suppose I'm drawing a curve like this. Okay, so suppose this is a right curve or right track. So as per the statement says, the curve at a particular cross section, the length of the inner curve is smaller than length of the outer curve. Okay, this is a basic mathematics or basic geometry, you can say. In a particular cross section, the length or the arc length of in the outer curve is more than the inner curve. That means if you consider this is a railway track, okay, or rail, and suppose a train is moving along this track, the distance traveled by the outer wheel will be more than the inner wheel. You got this? Got this idea? Since the length traveled by the inner wheel is less. Okay, that means the length available in a curve is less in case of inner track compared to outer track. The length in the outer track is more. Okay? The diameter of the outer track is more in curved path than the inner track. For this reason, the outer wheel has to cover a greater distance. Okay, that means it's basically the diameter of the outer curve is more compared to the inner curve. That because of that, the outer wheel have to travel more. The outer wheel has to cover a greater distance than the inner wheel. On a curved track, due to centrifugal force acting on a train is forcing outward direction. That means your if your okay, again I have to draw this. Suppose this is your curve. Okay, in this direction, if suppose in the right curve, the train is moving in this direction. The your centrifugal force is acting in this direction. It will try to push the train in lateral direction, in left. Okay, in left part. Okay, this is a basic physics. And due to the coning, because that means due to the coning of the wheel, circumference of the outer wheel increases and the inner wheel decreases. That means since we are provided coning of wheel, that means we are not writing a generally horizontal plane, we are making a cone. In that case, when you take a right curve, you can see the contact point of the rail with the wheel is come at this point, at the outer, in the larger diameter or inner diameter point. Okay, now here you can see the contact point in the smaller diameter. Look closely. Okay, when the train is moving in the right turn, the at that point or at the exactly at the peak turn point, if you take a photo, you can see the point of contact of the rail with the wheel is at this point. You can see the line of contact is at this point, and the line of contact in case of inner wheel is at the smaller diameter point. Okay, and this is because of the coning. Okay, and it will help the outer wheel to cover greater distance than the inner wheel. Okay, I also show you a animation video how it work. Okay, that means how a coning of wheel will help in stability of train. In this way, a smooth riding is produced by means of coning of wheel. So this is all about your coning of wheel. Okay. So what are the advantages of coning of wheel? So it provides a smooth riding, help vehicle in negotiable curves smoothly. That means especially in case of curve track, coning of wheel is very helpful. It reduces wear and tear of the wheel flank, and damage is caused because of the friction action of rim with inner face of the rail top. That means it will reduce the wear and tear. That means the chances of failure of the wheel tread and the wheel flanks is reduced by the coning of wheel. Okay, it gives an option of lateral drift of the hinge with the wheel. That means it gives a lateral drift means you can see the gap between the flanks and the point of contact. It will always give particular some 1 millimeter or some centimeter of gap between the point of contact with the flanks. Okay, it will give some lateral drift. That means there is a degree of freedom of movement in the lateral direction. It will not become a rigid part. Okay, and this way it will also reduce the wear and tear of the flanks part also, and also reduce friction between the rail and the flank. Okay, so there is always a gap between the flank and the point of contact with the rail face. Okay, it prevents some extent slipping of the wheel. Of course, it will prevent lateral skid and slipping because of this extended part of the flank. Okay, suppose if you're this in this car, it is taking the right turn, and because of the frictional force, centrifugal force, it it will tends to move the vehicle in left direction, but because of the extended part of the wheel flanks, it is resisted. Okay, this wheel flank, the external part of the wheel flank, it will resist the lateral movement or lateral skid or slip. Okay, and this is because of the coning of wheel only. Fine. So this is all about our advantage of coning of wheel. With this, some disadvantages also come. Okay, so let's discuss about some disadvantages of coning of wheel. Okay. Okay. So what are the disadvantages? The pressure on the horizontal component of force near the inner edge of the outer rail has a tendency to wear the rail quickly. That means the pressure on the horizontal component of force near the inner face of the outer rail. Here, I'm talking about here. You can see when the train is taking a right turn. Okay, you can see the gap between the flank and the point of contact between rail and the wheel is very close. That means there is a chance of friction, and because of the friction, there is a chance of failure or crack in the flank. In other words, we can say there is a possibility of uh, arises of wear and tear of the wheel flank, even along with the rail part because of the contact. Okay, you can see here. You can see the difference. The gap here and the gap here. Okay, this is a drawback. Basically, it has tendency to wear the rail quickly. Wear means there is a chances of failure. The horizontal component has to turn the rail outward, and hence the gauge may be winded. That means the horizontal thrust is always acted in this direction. I'll show you here, is act in this direction. Since the train is moving in right direction, so horizontal thrust is always tends to take that train in outward direction. Okay, although it resisted by the flank or coning of wheel, it will create a very large impact or stress on the rail part, even in the sleeper. Okay, and because of that excessive stresses, it may get fail the rail or sleeper part. Even the gauge, that means gauge means what? The distance between the inner face of the rail. It may alter because of the displacement of the rail or displacement of the sleeper. And to prevent that, we need to provide a base plate. That means if no base plate is provided, sleeper under the outer edge of the rail may be damaged. That means we need to provide a base plate. Base plate means I will show you here. I think base plate is already showing here. Let me check. Okay, wait. I'll show you a base plate. You can see the base plate here. These are the base plate. Okay, you can see in the diagram, animation diagram, even here also. These are the base plate. Okay, it is fixed. It is used to fix the rail with the sleeper. Fine. This one base plate. Clear. Here you can see the base plate. So if base plate is not provided, then coning of wheel may cause some damages to the rail gauge. Fine. So these are the disadvantage of coning of wheel. But we can minimize the drawback of coning of wheel. We can minimize the disadvantages of the coning of wheel. How? By this tilting of rail. By giving this tilting of rail, we can minimize the coning of wheel. Now, what is tilting of rail? In order to minimize the disadvantages caused by coning of wheel, the rails are tilted inward at an angle 1 in 20. This reduces wear on the rail as well as on the tread of the wheel. Okay, now what is tilting of rail? I will show you in the diagram that it will very easy to understand that. I'll show you. Okay, wait, let me check. Wait, okay. Yeah. Now here you can see this is a very typical line diagram of a wheel arrangement. Okay, so this is your wheel given in a conical shape. Okay, in the slope of 1 in 20. This is also 1 in 20. This is a wheel. This is a wheel. Okay, so suppose this is your taking in a left turn. Considering the left turn, it will be your outer wheel, it your inner wheel. Consider like that. Okay. Now tilting of rail means what? The rail. This is a rail, right? This is a rail. It is not fixed vertically. It is placed in a inclined position in a slope of 1 in 20. You can see the diagram. Even in this diagram, you can see that rail is not fixed in the vertical line. It is little bit inclined. Okay, in a slope of 1 in 20, same slope. Okay, in the same slope, it is also fixed like that. Okay, what is the advantage of this? Doing this by tilting the rail, you can say the point of contact between the rail top face, top surface with the wheel tread is maximum. Okay. Now, if you can imagine a vertical rail, okay, if you can, I'll draw a vertical rail here. If I give a rail like this, vertical, and a rail like this, you can see if I place a rail like this, the point of contact is only this much. This much. Okay, this much. Now, by providing a tilted rail, now your point of contact increases, right? You can see point of contact increases. It gives more stability. Clear? This is called tilting of rail. Okay, so why tilting of rail is provided? To minimize the disadvantages of coning of wheel. Okay, so tilting of rail has the following advantages. To it maintain the gauge properly, the wear at the head of rail is uniform, it increases the life of sleeper and rail. Okay, since the point of surface of the rail base is increases, so we can say the rail wear, any failure of the rail is uniform throughout the surface. So this is all about your tilting of rail. Okay, so till now any doubt? So this is all about your coning of wheel. How, what is coning of wheel? How it's provided? Why it's provided? What is the advantages of coning of wheel? What are the disadvantages of coning of wheel? And how to minimize the disadvantage of coning of wheel? We have discussed in this class. Is there any doubt till now?
Sir,
Yeah.
can you like please explain like this tilting of wheels again?
Which one?
The last topic. Tilting of wheels.
Tilting. Now see, I
Yeah.
already told you, na. See, can you see the screen? I am showing one line diagram. Can you see the screen?
Yes.
Yes, na? Okay. Now,
Yeah.
again, I will repeat here. Wait. First of all, you have to understand what is coning of wheel. Coning of wheel means coning of wheel means what? We are giving a slope. Okay, we're making a cone. So if I draw here again cone here, I'll show you. It is given a conical shape. This is a basic diagram of a wheel. Okay, so this wheel part is a part of this cone, and the cone of this 1 in 20. Okay, we have already discussed about advantages of cone. Okay, but along with that some disadvantages also come because uh, suppose we are giving a vertical rail. Can you see the extended part of the sleeper here, inclined part? It is provided to make or to install the rail in such a way that it become inclined in a slope of 1 in 20. Okay, so I'll draw again. Wait. Okay, so if I draw a vertical rail here, I already told you like this. Suppose this is a rail part. This is a rail. I'm placing in a very horizontal platform, horizontal sleeper. It will become a vertical rail. In the place, you can see the point of contact with the wheel tread. This part, you can see the point of contact is only this part. This and the other remaining part is not in contact with the wheel. That means whatever the failure will occur only along this part only, not in this part. Okay, the whole stress is taken by this part only, and the point of area is very less, isn't it? Now, to reduce the failure of coning of wheel, and it is because of the coning of wheel, isn't it? So it is to reduce the disadvantages like wear and tear. That means the failure of rail, failure of sleeper. What we have done? We have tilted the rail. We have tilted the rail in such a manner that the point of contact between the rail base and the sleeper, sorry, rail base and the wheel tread is increases. You can see this a whole rail surface in a point of in contact with the wheel. Now, whatever the stress is taken by not one single point or some small area of the rail is taken by whole rail surface. Okay, so whatever stress is is distributed through the rail part uniformly, not at one point. This is the main advantage of tilting of rail. Got it? Is it clear?
Yes, sir.
Clear, no?
Yes, sir.
Okay.
So like practical, is it does it done practically like on the
Correct. What? Again,
like
I can't hear you.
practically
So you can go through in the railway track. Okay, fine. So you can maybe you will not see clearly. It is very small slope. Okay, you can try to look closely. It may be identical. Okay, practically also. Let me check whether it is available here only. So here you can see I'm showing some diagram of wheel. This is a, you can see the rail wheel. This is your outer wheel, outer part. This is your inner part, and this is your tread. The okay, this is your tread part. This is your tread part, and this part is your rim. The inner part is called rim or tread. Okay, fine. And you can see it is not exactly clearly you can see, but it is in a conical shape. That means okay, it is in a kind of this conical shape. Got it? Is it clear?
Yes, sir.
Okay, let me check whether it is available or not. Tilting of rail. Okay, wait. Uh, there is no actual practical diagram. Okay, here because it is very. You can see some failure of rail. You can see here failure of the rail. It is not given here in any tilted part because it is given a very small slope, right? 1 in 20 only. So it is very small to identify. Fine. So anyway, okay. So I have prepared one video also for you for I to go through this. So till now, any doubt? If you don't have any doubt, so I'll close the recording. Then I will take your attendance and I'll show us one video so that you can understand the coding of it. Is it clear till now? Any doubt?
Yes, sir.
Yes, sir.
Okay, okay. So here I want to close the recording. After that, I will take your attendance. Then I will show you one video. Okay, a small video. You can also go through the YouTube channel. You can go through that video. No problem. Okay. So I'll first stop my recording here.